In this lecture, we are going to look at analyzing quadratic graphs. A ball is thrown straight upward with an initial speed of 14 feet per second from an initial height of 3 feet. This is modeled by the function b of x equals negative 5x squared plus 14x plus 3. The graph and table below were created using the function b of x. So the first thing I need to do is label my axes. So this one is going to be time, and we're going to measure time in seconds. And then this axis is going to be height, and we're going to measure the height in feet. Question A. At what time does the ball reach its maximum height? And how do you know? Well, the maximum height is going to be right here. So to figure out what time that is, I'm going to kind of come down here to the time axis, and I'm going to say that's about 1.5 seconds. And then how do you know? It's because the maximum height is at the top. Part B. What is the approximate height reached by the ball? Explain your answer. So again, the height is right here. So we're going to come over to the height axis, and the height is about 13 feet. So explain your answer. That is because that is where the maximum height touches the y-axis. Question 3. The point 3, 0 is an x-intercept of the graph. What does this mean in the context of the graph? So here is 3, 0. And what does that mean? That is when the ball touches the ground. Question D. The point 1, 12 is on the graph and in the table. So it's on the graph 1, 12 right here, and it's on the table right here. At that point in time in the scenario, is the ball traveling up or down? How can you tell? Well, the ball is still going to be traveling up for a couple reasons. The slope is positive, and there is a higher number at the maximum. Question E. The point 2, 11, so let me put 2, 11 right here, is on the graph and the table. At that point in time in the scenario, is the ball traveling up or down? Well, the ball is traveling down because the slope is negative and it's lower than the maximum.